So for this function, we have g of x equals 10x squared minus 17x plus 3 over 2x cubed minus 3x squared plus 2x minus 3. Okay, we are going to factor. So the numerator doesn't have any common factors, so we're going to factor the quadratic with bottoms up. The factors of 30 add up to negative 17. So we're talking some larger numbers, 15 and 2, both negative, but we got to divide by 10. Okay, so 15 tenths is the same thing as 3 halves, right? So 2x minus 3, and 2 tenths is the same thing as 1/5, so 5x minus 1. Let's check that out. 10x squared, good. Minus 2x minus 15x is minus 17x, and then plus 3. Okay. Now this denominator is a little bit more interesting because it's a cubic, but if I don't, the only kind of cubics I can give you are certain kinds and the kinds that can be factored. So what we're going to do is we're going to factor by grouping. So we always leave, okay, I can't say always. If it's a negative, you keep the negative with the 2, but with a plus you can leave it out. We're going to factor out the common factor, which is an x squared, and I'm left with 2x minus 1. Minus 3, just kidding. 2x minus 3. Here, I can't factor out anything, so what we do is we have to factor out at least a 1. So we're going to factor out a 1, and we're left with 2x minus 3. So whenever I factor that out, I'm left with factoring out the common factor, 2x minus 3, and then x squared plus 1. Okay. If you want to go ahead and pause this and see if you can find the domain, vertical asymptotes, holes, and intercepts, then that would be great. I'm going to go ahead and start doing that now. This equals 0 at positive 3 halves. X squared plus 1 never equals 0. It's a quadratic shifted up 1, so if you think about like on its own, x squared shifted up 1 never equals 0. So there are no terms from this. So the only question is, what is this one? Is it a vertical asymptote or is it a hole in the graph? Or I guess we could start with the initial thing, domain. The domain of this would be all real numbers, x cannot equal 3 halves. As to what that is, well, it's a common factor in the numerator and denominator, so we know there are no vertical asymptotes, and that it is in fact a hole in the graph. So then my question is, where, right? So this is kind of fun. We get to plug in 3 halves. Okay, into what's left over. 5 times 3 halves minus 1 divided by 3 halves squared plus 1. And you know me, I like doing math. So 15 halves minus common denominator would be 1 is 2 halves. And then that's 9/4 plus 1, 1 is 4/4, common denominator. So I've got 13 halves divided by 13/4, right? Interesting. So when you multiply by the reciprocal, 4/13, you're left with 2. Well, that worked out nicely. Okay. And intercept. So let's talk about x-intercept. X-intercept is when the numerator and only the numerator equals 0. So the numerator equals 0 here, but that's a hole in the graph, so the numerator only equals 0 at positive 1/5. So 1/5 comma 0. And then y-intercept is when x equals 0. So I like to go back to the original, and I cover up everything with an x, and I'm left with 3 divided by negative 3, which is negative 1. And there we go. Okay. I do want to talk about this, though, well, no. I already mentioned, no, it's already, we've already done it. Never mind, just kidding. We're going to keep going. Okay. We've got 3 more functions to mess with and explore, and then we'll be done. Okay, so same directions, just new function. The numerator has a common factor of x, and If you think about it as a quadratic now, x squared minus 7x plus 12. The factors of 12 that add up to negative 7 are negative 3 and negative 4. Yep. The denominator is the difference of perfect squares, so that would be x minus 4x plus 4. Okay, so this is that. And now let's talk about when the denominator equals 0. X equals 4 is an issue. X equals negative 4 is an issue. X equals, well, let's just go ahead and say domain. Domain, negative infinity to negative 4, negative 4 to positive 4, positive 4 to infinity. Okay, vertical asymptotes. Vertical asymptote is when the denominator and only the denominator equals 0. This is a shared factor, so this is when only the denominator equals 0. So we have a vertical asymptote at x equals negative 4. Hole in the graph occurs in both the numerator and denominator, so we're talking these two factors. So that would be at 4 comma, so we're going to plug in 4 into what's left over. So I've got 4 times 4 minus 3, which is 1, over 4 plus 4, which is 8. So at 4 comma 1 half. Okay? And intercepts. Let's talk about x-intercepts. X-intercepts occur when the numerator and only the numerator equals 0, so that's out. So I've got two different times actually when the numerator equals 0, at 0 and at 3. So I've got an x-intercept of 0, 0 and 3, 0. But that actually makes it easy because the y-intercept is when x equals 0, and if 0, 0 is an x-intercept, it's also the y-intercept. I can also go back and think, okay, x-intercept is when, sorry, y-intercept is when x equals 0. If I were to cancel out everything that has an x in it, right, I would get 0 over negative 16. 0 divided by negative 16 is 0. Okay. And there we go. These all have complicated situations going on as far as horizontal asymptotes go, but we're not talking about that today. We'll talk about that tomorrow. So, all right, next one, second to last one. G of x equals 10x squared minus 17x plus 3. And 2x cubed, wait, didn't I just do that? Didn't we just do that? We don't have that one to do. How did I repeat that? Oh, I repeated the page and just changed that and didn't see that. Cute. Okay, so let's do this one and then we'll be done. We've got 4x squared minus 4. Just kidding. 4x squared minus 4 over 3x to the fourth plus 4x cubed minus 7x squared. So I made this one to be able to explore something with you. And then I might actually talk about something else real quick, but it's going to be important, so hang around. The numerator, I'm going to factor out a 4, and I'm left with x squared minus 1. X squared minus 1 is the difference of perfect squares, so x plus 1, x minus 1, divided by. The denominator has a common factor of x squared, so I'm going to factor out an x squared, and then we're left with 3x squared plus 4x minus 7. So we're looking for the factors of negative 21 that add up to 4. 7 and negative 3, divide by 3. So I get x squared times 3x plus 7 times x minus 1. Okay, so let's talk about this. Common factor, or let's just go ahead and let's start talking zeros in the denominator. X equals 0 is an issue. It's squared, whatever. If I plug in 0, I get that. Negative 7/3 is an issue, and 1 is an issue. If I had to look at, common factors, I would say, well, that already indicates that this is a whole. And the fact that these aren't repeated means vertical asymptote. The thing about it is that these are kind of interesting. They're different, right? This one has a different behavior around it than this one, necessarily. So let's talk about why. If I asked you to graph 1 over x squared, so 1 over x, we already know what it looks like. That's the basic reciprocal function, right? But if I ask you to graph this one, well, the thing about squaring numbers is that it makes them always positive, as long as they're real. So when I plug in 1, I get 1 over 1 squared, which is 1. When I plug in 2, I get 1/4. So it actually decreases a whole lot faster. And it also increases faster. So as far as like this goes, they would meet here, but then it would go up higher, and then it would go down lower. So it would do me, and then me. It would pass it as far as increasing and decreasing goes. So we've got this over here. I should have done a different color. Okay, so decreases faster. That makes sense because it's dividing by a larger number than this right here, right? When you square it. Or a smaller number if you're getting closer to 0, between -1 and 1. But let's talk about this side. If I plug in -1, -1 squared is 1. It's up here at 1 again. If I plug in -2, I get positive 1/4 again. So in fact, I hope you guys remember it, but we talked about bouncing versus crossing. The vertical asymptote has a multiplicity of 2. That's an even multiplicity, which means it doesn't bounce like, you know, an x-intercept bounces, but it does do this thing where they both go in the same direction. So if one's going to positive infinity, so is the other side. If they go to negative infinity, then they both do. Okay, so it's kind of interesting, and we'll use that later on when we're actually sketching. But right now, it's just thinking about it. All that's to say, I don't want you to be freaked out if something like that happens. It just means you have a vertical asymptote, and they just go in the same direction. Okay, so you know, thinking about this, we have a graph right here that has a vertical asymptote in 2 different spots. So we have x equals 0 vertical asymptote. We have -7/3 and -2 1/3. I'm just pretending. We have a hole in the graph at x equals 1 something. I don't know what it is yet. And we have an x-intercept at -1. So we're actually crossing the x-axis. So I'll talk more about that later. But if it say I'm just pretending. I have no idea. Say it did something like this. That would mean it would have to come back from here, and it could maybe go through here and then go up and then do this. We don't know. I mean, I'd have to graph it and sketch it, but anyway, I'm just saying, like, this is kind of interesting because they're both coming from this direction. I have to cross there, and then I know I don't have that, but well, we'll see more of this in the information we're about to determine. Domain. All real numbers except 0, -7/3, and 1, or -infinity, -7/3, -7/3 to 0, 0 to... did I say... Oh, -1. Oh, duh, there's a hole in the graph at 1. Okay, not a -1. And 1 to infinity. Okay, that was terrible. And vertical asymptotes. So vertical asymptotes at x equals 0 and x equals -7/3. Hole in the graph at 1 comma. So we're going to cover that up and plug in 1 into everything else. 4 times 1 plus 1, so 4 times 2, that's 8. Plugging in 1, I get 1, and I get 3, so 10. So I get 4/5. Okay? And intercept, so x-intercept. X-intercept is when the numerator and only the numerator equals 0, so that would be at -1, because that's when the entire function equals 0, but not the hole in the graph. And y-intercept, jeez, I keep doing that. Y-intercept is when x equals 0, so if we go back to here and we look, if I were to cover up, you know, all the x's because x equals 0, I would get -4 divided by 0. Okay, so it's dividing by 0 because of that right there, because we have a vertical asymptote. We have a vertical asymptote at x equals 0, which means there isn't a y-intercept because we have a vertical asymptote. Okay, so I just wanted to say one more thing and kind of address the whole numbers issue. Although I think I already didn't I? No, I don't even remember. Bah! You know what? I'm just going to leave it, and if you have any questions on your homework, you can let me know. Alright. Or, well, it's not homework, it's just practice, if you want to do it. Which I suggest you do, at least some. All right, bye.